Hello students, I'm Mevludin, teacher of mathematics here in Yahya Kemal Karkosh. Some of you may know me, but some of you, well, I don't know you either, most of you. So we will start with the first problem. We will study now geometry. As you know, you're probably informed about that from your teachers. With the first problem, maybe some of you solved it already because it's staying here for a while, more than 10 minutes. It's been here. It says in a rectangle ABCD, points F and G lie on line AB such that AF, FG, and GB are equal. And it's given that there is another point E, which is the midpoint of DC. Also, AC intersects the intersections of line AC with EF. It's given that it's point H, and EG intersection of AC and EG, it's point J. It's given the area of this rectangle, which is 70, and it says find the area of the triangle EHJ. Let's have first, we will construct this one. I've already done this one, but for you maybe it will take some time, around 2-3 minutes like that. So first we have this rectangle A, B, C, D. Take the points F and G such that AF equals FG equals GB. I didn't construct these points, so they are not in scale. Maybe this looks it's smaller here, but it's not a big deal. We will suppose that they are equal. And then the point E here should be the midpoint of CD, as it's asking here on the problem. E is the midpoint of DC. It says also that AC intersects EF at point H. Here we have H, and then EG at point J. Here we have J. All right, so far so good. It's given the area of this rectangle. Great. Let's show something more. It says that we can denote them with X just to simplify writing it a lot of times. Like we can simplify, we just write once X and we can use X for that. AF equals to FG equals GB, which was given from the problem. Let's denote that with X. So we are denoting it also here with X, and here with X, and here with X, because they are all equal. BC, we denote that with Y. You can pick any letter that you want, but it's not a big deal. It's given that the area of the rectangle ABCD is 70. Well, X plus X plus X, 3X times Y is 70, so we have one equation here. Now, if we show that the triangle ECH is congruent to the triangle HAF, so this triangle is congruent to this triangle here. It's easy to show this one because look, we have two parallel lines and three pairs of congruent angles. It's obvious that these two triangles are congruent. Similar, sorry. These two triangles are similar. Something you may have studied this one. The length ratio of these two triangles is 3:2. How do you figure out the length ratio, and what does the length ratio means? Let's write something here. If you have two similar triangles, let's say this is A1, this is A2, B1, B2, C1, C2. length ratio is A2 over A1 or A1 over A2. It depends how you take them. In this case, the length ratio of these two triangles is 3 to 2. How do we know that? This side here, it's 3. This side here. Or better, give a try first if you can continue to solve the problem from here. It may be a good hint for you. When you will be done, inform me, like write on the comments, so that we will continue with the next problem. Of course, we will solve all the problem, but it's better if you solve it on your own. It's asking for the area of the triangle EHJ. So I shaded with the blue marker now. That's the question. All right, let's continue to show why this length ratio is 3 to 2. Look, the side here, EC, it's the point E is the midpoint of CD, which means it's half of the length of AB, because AB is equal to DC. AB is 3x, so this here is 3x over 2. Because these two triangles EHC and the triangle EHF are similar triangles, the side EC is proportional to the side AF. So just divide EC over AF, it will be 3 over 2. So we got the ratio. Great. Now, can we find With this new information here, can we find the area of the triangle ECH? What do we need the area of the triangle ECH? If you look here, if you find the area of ECH and subtract the area of ECJ, you will be left only with the area of EHJ. All right. Now, the area of the triangle ECH, I hope that you constructed that rectangle because I need to keep showing the same sketch again. The area of the triangle ECH is 1 over 2 CE times the height at the vertex H. So it's 1 over 2, maybe it looks like a mess here, but it's equal 1 over 2, it's not negative 1. It's 1 over 2 times CH was 3x over 2 times, well, height is 3y over 5. Think a little bit why age, height at the point H is 3y over 5. You will have 2 minutes to think, and then we will continue explaining the rest. We have an answer, so it's correct. It's from the similarity of these two triangles here. It means that the height from point H is 3y over 5. Now we just need some calculations. 3xy times 3 over 20, it's 70 because this one is 70. It's given here, as you see. So we found the area of that triangle is 21 over 2. You will have 5 minutes to finish all the problem now, and we will continue with the next one. Now what you need to do, a hint, now we used this triangle EHC and HAF. We found the area of EHC. Do the same thing for the triangle AEJC and AJG, and you will find the area of EJC. When you will finish, please write on the comments. If you already solved the problem, please write the answer on the comments. It will be there, but not for like 1 month. Like you can watch it maybe 1 week. I will leave it, then I will delete the video. All right, let's continue solving the rest. So we will just show here the solution, like similar with the, just as we did with the triangle ECH, we are doing with this triangle ECJ. Now it's 1/2 EC times height of the point J. So EC is again 3x over 2, and now height at the point J is 3y, sorry, height at the point J is 3y over 7 for the same reason, because there are similar triangles, just as Philip said. So here the area is 15 over 2. And we have the last part. With this one, the problem is all solved. The area of the triangle EHJ is the area of ECH minus ECJ. Substitute and we get 3. All right, let's continue with the second problem. Let ABC be a triangle and let D be a point on the side BC such that DC is twice BD. Find the angles of the triangle ABC if it's given that the angle ACB is 45 degrees and ADB is 60 degrees. Copy the problem, please. It's equal to 60 degrees. Yeah, now it's visible. let's show something from the solution. If you're trying on your own, please keep trying. I will show something. So if it's given that DC is twice dB, just to make it simple, we will write this one with x and this one with 2x. If you don't want, don't write it. It's not a big problem. Now let's take a point, and this is maybe the tricky part of this problem. Let's take a point here, which is point E. The point E, which is given just like here. BE should be perpendicular to AD, and point E should be element of the line segment AD, so it should lie somewhere here. It's a good hint. You can continue now. Give a try. Thank you very much, Philip. I think, sorry, 2DC is dB. Thank you very much. It's the problem on the text here. Let's continue. So from this triangle, from the triangle BAD, BED, because this triangle BED is a triangle 30, 60, 90. As you see, it's a right angle triangle with one angle 60. We see that DE is BD over 2. While this is 2x, it means that this side must be x. Now let's draw a line CE here. I'm drawing it with a blue marker now. Let's see, what can we do now? If you draw a line here, a line, EC, look, the triangle EDC, or DCE, is an isosceles triangle. This angle, it's easy to show, it's 120 degrees. So what's left? This angle should be 30 degrees. This angle should be also 30 degrees. Great. Now, do you have any question till now? All right, let's continue. So the angle CEA is 150 degrees. Let's see. The angle CEA is 150. Why? All this angle is 270 minus 90. It's 180 minus 30, or you could have just find it from here. 180 minus 30. So this angle is 150 degrees. If that angle is 150 degrees, we know that this angle is 15 degrees. What's left? That this angle here also is 15 degrees. It means that again, this triangle AEC is an isosceles triangle, while these two sides are equal. All right, the same for the other two angles, D from the angles DBE and ECD. For these two angles, they are both of them 30 degrees. It's easy to show. I'm not writing them. All right, I'll do it. This is 30 and this is given here 30. So again, the triangle BEC is an isosceles. It means that this side is equal to this side. So the side AE is equal to EB. We know that this angle here is 90 degrees. It means that these two angles are 45 degrees. This angle is 45 degrees and this angle, because it's a right angle isosceles triangle. And we already have some solutions. While we found those angles, we're at the end of the solution for this problem. Three angles, alpha 60, 75, and 45 degrees. For those who didn't copy, here you have the problem, the last lines of the problem. You will have 5 minutes to finish it. Or maybe 3 minutes. Can we continue with the third problem? All right. The third problem says, let ABC be a triangle and A prime, B prime, C prime be the midpoints of BC, CA, and AB correspondingly. And D be a point on BC, and AD should be perpendicular to BC. So it's basically this point here. You take the height of A at the point A, at the vertex A here, and you get the point D. Show that the angle DC prime A prime is DB prime A prime is equal to the beta minus gamma. We have one condition here. You can answer on comments why AC should be bigger than AB. I will wait your comments and then I will continue showing the solution. I'm waiting for your answers. The question is why AC should be bigger than AB. Yes, because we don't measure negative angles when we have just normal geometry. We measure negative angles when we introduce the direction of the angles. So basically there is no negative angle until you introduce directions of the angles. Great. It's not difficult to show that the arrangement of points will be B, D, A prime, C. What does this notation means? That it means that on this line BC, which is here, the segment line BC, the arrangement of points will be looking like this. We know that it won't be B, A prime, D, C. Also, it's easy to show AB is parallel to A prime, B prime, because these two triangles are similar. This angle is equal to this angle. Let's denote that. Let's denote that if this angle will be beta, well, this angle also will be beta. From the triangle ADC, it's a right angle triangle, so it's a right triangle. It's given from the problem that these two sides are equal, B prime C and B prime A are equal from the problem because it's the midpoint. The triangle ADC, right angle triangle, this line is the median for the triangle ADC. So what does this tells us? That this side is also equal. Well, if this angle will be gamma, let's say, because it's point C, this angle will also be gamma. Great. This is easy now. CA prime B prime, the angle A prime B prime will be the sum of CD B prime and A B prime D. We already denoted this one with beta and this one with gamma, so the angle A B prime D is beta minus gamma. For the other angle, it's just the same problem flipped, like you're flipping the image on the left side. You can continue solving for the angle DC prime A prime. It's not difficult. All right, it looks like you're done. We will continue with the fourth problem. This is an easier problem. Let's check it. In a right angle triangle ABC, CF is the median drawn to the hypotenuse AB, and CE is the angle bisector. I didn't construct this, so I'm constructing with you together. You happen to write the problem also. Meanwhile, I will construct this. So this is the median, CF is the median, and CE, it should be somewhere here. CE is the angle bisector, and CD is, CD is the height, the altitude, and this angle bisector, let's suppose it's somewhere here. I'm not constructing this, I'm drawing them free-handed. So we have three lines, CF, the median, CE, which is the angle bisector, and CD, which is the altitude of this triangle. We have to prove that the angle DCE, this angle, is equal to this angle. We need to show that these two angles are equal. I'll give you 5 minutes to try, and then we will reveal the solution. And meanwhile, if you're done, you can write your answers on the comment. All right, let's start denoting some angles. Let's say this angle is alpha, this angle, let's say it's beta. So you can see it already from here. We have the solution, but first let's show it to you. If this angle is alpha, well, this side and this side here, when I say this side, I mean BF, they both are equal. It's a right angle triangle, so they must be equal to CF because F is the midpoint of the hypotenuse AB. As you see, we have an isosceles triangle, CFA. It's an isosceles triangle. It means that this angle is alpha. Well, the triangle CAB and the triangle CDB are similar triangles. It means that they have all angles equal. If this is beta 90 degrees, this must be alpha. Great. Now, because this angle is given that it's equal to this angle, y, because the line CE is the angle bisector, it means that it bisects the angle. So the angle ACF plus the angle FCE is equal to the angle ECD plus the angle DCB. Both of them are alpha. One of them I denoted here on my notebook. I denoted it, this one with X, this one with Y. So X is equal to Y, thus those two angles are equal. Are you done? All right, let's continue. With this problem. Svetozar, it's Yemen. Did you solve the problem? All right, let's continue constructing the problem. It says that the angle bisector AD here, let's construct this one. And then this angle bisector here. So this is point D, this is point E. Then we have perpendicular lines to the hypotenuse. It means that these lines, this one, and also this one. So this is perpendicular and this is perpendicular. This dn, this one dm. It's asking to show that this angle is 45 degrees. All right. From the triangle BCE, and the triangle BMD, BEM, BME. Those two triangles are congruent. They are similar but congruent also. Let's write them congruent here. So it means that the side BC is equal to BM. Well, if these two sides are equal, it means that the corresponding angles are also equal. I denoted this beta and this one beta because they are the line BE is angle bisector, so this is beta, this one is beta. It means that this angle here is 90 minus beta. That angle is a right angle here. So this is 90 minus beta. It means that this angle is, beta. Also the same logic applies for this one. It's beta. Let's do the same thing, but now for the triangle ACD and the triangle AND. These two triangles are similar, so AN is equal to AC. If AN is equal to AC, it means that this angle, let's denote this alpha, this one alpha, this angle here is 90 minus alpha. Well, this one will be alpha then. The same applies for this angle. I'm not messing it. This is 90 minus alpha, the same as this one, and this angle is alpha. Well, now basically we're done because this whole angle is 90 degrees, as you know. Alpha plus beta is 45 because 2 alpha plus 2 beta. 2 alpha plus 2 beta is 90 degrees, so alpha plus beta is 45 degrees. And we showed that the angle MCN is 45 degrees. Let's continue with the sixth problem for today. Give a try, and if you find a solution, please inform us in comments. Seven problems, or maybe eight. Alright, students, if you're not familiar with this theorem, maybe it's impossible to solve that problem. It's called Siva's theorem, and it says if you have a triangle and there is a point M inside that triangle ABC, then this equation works there. So AD over DB times B. So now you have a hint. It's called Siva's theorem. Now you have this information. Give a try once more. How many of you have heard about Siva's theorem? All right, let's continue. So it says that if M lies on the height CH, so we have the height here, CH. And there is a point here somewhere, M. The line AM intersects BC. AM intersects BC at point, which point? Point E. And BM intersects AC at point F. BM and point F. Now it says prove that these two angles here are equal. Just let we need to show that these two angles AFHN and MHE are equal. Actually, it's not difficult. If you know Siva's theorem, which was this one, it's not difficult at all. Let's construct a line here, new line, which is parallel to AB. I'll try to make it parallel, but I'm not using construction tools, so we will accept this one. Good. Let's say this line is line P, which passes through point C and is parallel to AB. Let's continue these two lines, HF and HE, and let's denote these 2 points. Let's denote these 2 points with HE. We'll denote this one P and this one Q. The intersection of HF with the line P with Q. Great. Now, as you see, this angle is a right angle here. Why? Because CH was perpendicular and line P is parallel to AB, so it must be perpendicular. Our goal is to find that this angle FHM and MHE, those two angles are equal. So I'll leave it to you to continue to try to solve this one once more. Now what you need to do, well, if you just show that these two triangles are congruent, you're done. Did you solve the problem? You're not giving feedback to me. All right. Let's see these two triangles. The triangle AHF and the triangle FCQ. AHF and FCQ. These two triangles are similar. You can see it's not difficult for this one. So if these two triangles are similar, that means that their sides are proportional. AH over CQ, AH over CQ is like AF over FC. The same applies for the triangle HBE and the triangle ECP. Those two triangles are these ones, this triangle and this triangle. They are similar. Look, parallel sides. All angles are equal, so we have two similar triangles. From those two triangles, we have that HB over CP is BE over EC. Well, we can rewrite this equation as AH times FC equals AF times CQ, and the same for this triangle. HB times EC is BE times CP. Let's take a look again on this Siva's theorem, which said AH over HB times BE over EC times CF over FA equals to 1. Now on this equation we can just substitute something. Look, we have AH, now we can see everything. Look, AH and CF, well here it's FC, it's the same. CF, FC, it's the same. We can substitute these two with AF and CQ, and the same for HB times EC is BE times CP. All right, I'm substituting them, so I have AF times CQ times BE over CP times BE times FA. This cancels, BE over BE cancels, AF and FA cancels, so it means that CQ is CP. So this length CQ is CP. It means that these two angles are congruent. Is that clear? Are you done? Students, you are not answering. Like, is do we have to repeat once more the solution? Great. Let's continue with the seventh problem. Prove that point P lies on the median AM of the triangle ABC if and only if P is internal point of the triangle ABC and area of the triangle, sorry, I forgot to write here triangle, triangle. The area of the triangle PAB and the area of the triangle PCA are equal. Look, we have here the logical operator if and only if. Do you remember what was the logical operator if and only if? I put a C on the right side and B on the left, but it won't change anything if you swap the sides. Philip, I think I focused the camera, but I don't know. Check the settings, maybe it's not high definition. Check the settings there, increase the resolution. If you're done, please write that on the comments. As you see, we have two parts here. The logical operator if and only if means that from the first part we get the second part, and from the second part we get the first part. So in this case it says the first proposition is the point P lies on the median AM of the triangle ABC, and the second proposition is P is the internal point of the triangle ABC, and the area of the triangle PAB is equal to the area of the triangle PCA. So this part is the second proposition, and this part here is the first proposition. Let's see, now we have this triangle, and here is the solution for the Alright, we use this notation for the solution of the if condition, and this one for only if, so in the both directions. It's just equal, bigger, two dots and brackets. So let's say that the point P lies on the median AM, the point P lies on the median AM of the triangle ABC. So we are taking that assumption. So the point P lies somewhere here. We know that the area, because this is the median, point M divides the segment BC into two equal parts. So the area of the triangle ABM is equal to the area of the triangle AMC. They are two triangles with equal bases and same height, so they are equal. The same applies for the area of the triangle PBM and the area of the triangle BMC. So there are those two triangles, PBM and PMC. Well, if I shade these two triangles, the triangle ABM and the triangle PBM, one with blue marker and the other with brown marker, then the area of the triangle ABP, the area of the triangle ABP is equal to ABM minus PBM. Well, the same applies for these two triangles, so that means the area of the triangle PBA and BCA is equal, PCA is equal. We showed the if condition. Now we need to continue with condition and only if. So it means the reverse. Now we need to assume that P is an internal point of the triangle ABC and the area PAB and PAC is equal. Both those two areas are equal. Did any of you solve the if and only if, I mean in both directions? Let us show the second part of the solution. We use the same notation, but just now reverse side. Here it points on the right side, here it points on the left side. Sorry for the focus. Let P be an internal point and the area of the triangle. Well, as you see, I forgot all the triangles here. So let P be an internal point and the area of PAB equals to the area of PAC, like PAC. Let's denote M prime. Let's use a notation here. M prime So let's use the notation M prime for the intersection of AP and BC. It means that this line. Let this one be M prime. Of the triangles PAB, as you can read it here, the triangles PAB and the triangle PAC share a side, PA. These two triangles share a side. So they share the side AP. It means that the height of these two triangles, if they have equal areas, the height of these two triangles must be equal, the heights of these two triangles. So if the height of this triangle BPA is equal to the height of the triangle CPA, it means that the height of B M prime P prime is the same as the height of M prime C prime P prime, M prime CP, sorry. Well, the triangle ABM prime is equal to the sum of this area and this area. I'm denoting with the green all equal areas because they are given. The green one are given, the blue one we showed. So it means that the area of ABM prime is equal to the area of ACM prime. As you see, the triangles ABM prime and ACM prime, they have the same height. So they must have the same base. The base of these two triangles must be equal. So B m prime is equal to m prime c. Well, if B m prime is equal to m prime c, it means that the point m prime lies on the median. The point P lies on the median, m prime is the midpoint of BC. Is that clear? And do you have any question? Then I have some homeworks for you. As you know, I'm not going to check this, but you can try. Sure, I can share it with you, but with the other students, I don't have neither their numbers, I don't have contact with the others. Just with you from Karposh, I can share it with you. It says from 3 o'clock it will have MMO functions, but I don't have the other teacher's uh, account yet. I need to check, so maybe I will pause a little bit and then I will inform you, because I cannot do live streaming and checking my Viber account. I just sent you the account where you can watch MMO functions. Alright, that's it. See you. Bye.